Yes, good evening, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. Guys, sorry for the delay. Actually, some technical error was there. That's why the delay happens. So, guys, today is the first session. Is the first session for theory of machine subject, and that is in the wonderful startup series. So, guys, in this series for theory of machines, what my target is to take. Actually, if you are talking about the theory of machine, it is a very vast syllabus, you know that. And when we are talking about out of this, the very first topic is simple mechanism. And whenever we are talking about this simple mechanism, from this topic, one question is coming every year. And when we are talking about the question which is coming from this chapter is generally from three topics. One is Grashof's law, other is degree of freedom, and third is inversion. So these are the three topics from which questions are coming. So guys, my target here in this series is to complete these topics. Okay, so in these three classes I will be covering these three topics, and thereby we will be securing your 2 marks. Okay, for sure. So please tell me, am I properly audible and visible to all of you or not? Then we will be starting the session, guys. Okay, then we will be starting the session. So guys, let us move further. This is some detail about me. My name is Dheeraj Sardana. I'm having around 10 plus years of experience, and this subject is related to the theory of machines. Okay, let me share the session so that other students can also join us. Okay, so then we will be starting the session. Okay, fine, guys. Please tell me, am I properly audible and visible to all of you or not? Fine. So guys, now before we start, there is a workshop which happened today, and you can also go for that. Now we are starting the session, and before we go to the Grashof law is going to give you some rules related to the 4-bar mechanism. So before we go into that, first let us try to understand the 4-bar mechanism. First of all, my dear, when we say 4-bar, it tells us that there will be 4 links. Okay, then my dear, when we are talking about the term mechanism, what is mechanism? Then my dear, mechanism is something which is going to give us a constrained relative motion. So when we are talking about the mechanism, I will be calling it as a kinematic chain, with one link fix, then we will be calling it as a mechanism. Whenever you want to take any work output from something, then my dear, we need to fix at least one of the link, because inputs are given with respect to the fixed link, output are taken out with respect to the fixed link. If that is the case, one link needs to be fixed, then only we will be making the mechanism. For example, if you are talking, I am giving you a basic example. This is not the example of mechanism, but I want to tell you the example for input and output. Whenever you were in the first year of engineering, you must be having some drafter kind of thing. And what you were doing with that, to use that drafter, first of all, you were fixing that drafter to the table so that you can give the input and you can get the output with respect to something fixed. So that is why fixed link is very, very important. So here we are talking about the 4-bar mechanism. So here we will be having the 4 links. You can see this is link number 1, link number 2, link number 3, link number 4. So my dear, when we have 4 number of links, to get the mechanism, we have 4 options, because any of the link can be fixed to get the mechanism. So my dear, from 4 links, we can get 4 inversions. What is inversion? Actually, we can get 4 mechanisms. Because when we have 4 links, you can fix link number 1, link number 2, link number 3, link number 4. So when you will be fixing link number 1, you will get mechanism number 1. When you will fix link number 2, you will get mechanism number 2. When you will fix link number 3, you will get mechanism number 3. So in that way, by fixing individual links one at a time, you will be getting different mechanisms. Okay. So the point is, if we will be getting that number of mechanisms, they are said to be inversions. So inversions are nothing but the group of mechanism which we are obtaining by fixing a link of a kinematic chain one by one, but only one at a time. This is the principle how to get the mechanism. 4 bar, 4 number of links. For 4 number of links, we can get up to 4 mechanism. Okay. So this is the 4 bar mechanism. And here, whatever the link you will be keeping fixed, that will be called as the fixed link. I already told you input is given with respect to fixed link. Output is taken with respect to the fixed link. So it is going to be the most important link. Most important link. This is the position which our Prime Minister enjoys. This is the position which our father enjoys at the home. The boss, the position of the boss, where everything is controlled by him, both inputs and outputs. So that is why this condition, this situation, this seat is said to be the most important one. So my dear, because it governs both input and output. Then my dear, we are coming to this link number 2 and this link number 4. They are input and output links. They are connected, directly connected with the Prime Minister. Directly connected with the Prime Minister. They are like bureaucrats, they are like ministers, directly connected. So they do not have the best seat like Prime Minister, but you can say they are at the second best position. So we can call these input and output links as second best position. Why I am using this terminology? To help you out with the Grashof law. जैसे बोलते हैं ना नींव रखना, तो यहाँ ग्रेशॉफ लॉ पढ़ाने के लिए आपको नींव रखी जा रही है. So we are going to talk about link number 2, link number 4, and they are the second best position. Why? Because they are directly connected with the fixed link, and technically explained, any link, if it is directly connected with the fixed link, it will be having a well-defined motion. Well-defined means rotation, translation, that kind of motions. They are said to be the well-defined motion. Now, my dear, we are coming up to the link number 3, that is said to be coupler or coupling rod. It is not directly attached with the fixed link, and this link is said to be the worst position. This is said to be the worst position. This is the position of a common man in the country who is not directly connected, so is not having any benefits directly. But yes, the things are coming via these. That's why they are not coming up completely to this common man, to this coupler. The point is, technically said, this link will be having a not well-defined motion. So I would like to say the motion with this link is said to be the general motion, and general motion is not a defined motion. And we will be saying it is not a defined motion. It is neither, you can say, completely rotation nor completely reciprocation. It is neither translation nor rotation. It is going to be a rough combination of those motions. So that is why we will be saying it is not a well-defined motion. So general motion is not a well-defined motion. Not a well-defined motion. So that is the point which I want to tell you about the coupler. So why we have used this terminology? Because this is becoming very useful at the time of Grashof law. Because otherwise it will be difficult to understand and learn the Grashof law, but this will help you. So you get to know the best position in a 4-bar mechanism is the fixed link, because it governs both input and output. The worst is the coupler, which is just in front of the fixed link. So guys, this is about the 4-bar mechanism. I already told you inversions. So if we are having a 4-bar mechanism like I am making like this, this is A, B, C, D. We have 1, 2, 3 and 4. So my dear, we have 4 links, 4 options. We can fix link number 1, we can fix link number 2, we can fix link number 3, we can fix link number 4. Okay. And we are always need to observe the motion of input and output link. So when we are going to observe the motion of input and output link, as you know, both input and output link will be connected with the fixed link. So the beauty is, in the simple 4-bar mechanism, input will be having the rotation motion, output will also be having the rotation motion. They may not rotate completely. They may rotate completely or partially, like this or like this. Both complete and partial rotation is possible. But it is going to be rotation for sure. So if that is the case, my dear, Either I will be having the complete rotation or I will be having the partial rotation. Complete rotation is like this. Partial rotation is like this. So I am giving a name to the complete rotation. I will say that complete rotation means crank. Partial rotation means rocker. What do you mean by that? If any link will be rotating completely, I will be giving the name to it as crank. And if any link will be having the partial rotation, I will be giving the name it to as what? Yes, rocker. So guys, just like and share the session. I am also doing the same, and so that other student can also join, because this is very important series, very important session, and why we are keeping this kind of thing only for your benefit. Okay, so that you can secure your 2 marks. Okay, sound is okay, fine guys, wonderful. So moving further, so my dear, now you are having the 4 option. You will be fixing 1 2 3 4. You will get 4 mechanisms. All 4 group is said to be inversion. So let us say when I am fixing link number 4 here, link number 1, let us say. When link number 1 is fixed, what I got, one is input, other is output. I found that on fixing link number 1, like if this link is going to be fixed, then this and this will become input and output. Then my dear, input will be rotating completely. I have seen that. Output will also rotate completely. So mechanism was running like this. So when that is going to happen, I will say input is going to be crank, output is going to be crank, and the name of the mechanism will be double crank mechanism. The name of the mechanism will be double crank mechanism. This is the beauty. Now we are moving to the second thing, my dear. If we are going to fix link number 2, if we are going to fix the link number 2, when we will be fixing link number 2, my dear, what we found, that input link was completely rotating, output was partially. So my dear, for that we will be saying that input link is going to be a crank and output link is going to be a rocker. Okay, you may be saying, sir, how you would be knowing that? Dear, by making the mechanism. This is the observation which I am going to observe actually. So the first observation will be double crank, second observation will be crank rocker. This observation will be crank rocker. Okay, then my dear, I am going to fix link number 3. I am saying every time I will be fixing only one link. When I will be fixing link number 3, I will be getting here rocker and here crank. Here rocker and here crank. Then my dear, I would be getting rocker crank mechanism. Now you just try to see what is going to happen. Double crank means what? This. Crank rocker means what? This. Rocker crank means this is rocker, this is going to be crank. So my dear, if you see the rocker crank and crank rocker, like if I am standing like this, this is crank rocker. If I will be just reverting by 180 degree, it will become rocker crank. So don't you feel these two are having the same relative motion? Rotation to oscillation. This is having rotation to rotation. So they both have the same motion, rotation to oscillation. Input output are interchangeable when we are defining the relative motion. Relative is with respect to other, no? Yes, good evening, Vineet. So we would be saying this is rotation to oscillation both. And if any two inversions are having the same relative motion, we will be calling them as the same inversion. So my dear, they will not be making two different inversions, but they will be making the same inversion. So the name of this is going to be the crank rocker or rocker crank. So my dear, now we are going to fix link number 4. When you will be fixing link number 4, here we are getting the rocker. Here also we are getting the rocker. So when we are getting both rocker, then the mechanism name is going to be double rocker mechanism. It will be double rocker mechanism. So my dear, if you see here, relative motion is going to be rotation to oscillation. Sorry, rotation to rotation. Here rotation to oscillation and here oscillation to oscillation. So you can see there are 3 types of relative motion we are observing. होने वाले हैं Vineet, they will be starting soon. Okay, so don't worry about that. After this series, maybe the practice will be coming. So when we are talking about out of these 4 inversion, we are getting 3 types of relative motion. When we are saying three types of relative motion, it means we are talking about three inversions. So in this, the possibility was to have four inversions, but in reality we are getting three inversions. So my dear, whenever we say if we are having a mechanism with L number of links, the possibility is we can get up to maximum of four inversions. But every time we will not be getting four. Here we are getting three inversions because two inversions became the same. So that is why I said the maximum number of inversion is equal to the number of links. Now my dear, what is this beautiful Grashof law? Till now we have seen the possibilities that we can have one mechanism as double crank. We can have other mechanism as crank rocker. And we can have the next mechanism as rocker. So we get to know till now that for a simple 4-bar mechanism, these three types of inversions are possible. When we get to know that three types of inversions are possible, now the point is when we are going to get which inversion. And the answer to that question was given by Grashof. So Grashof answered कि when you will get double crank, when you will get crank rocker, and when you will be getting the double rocker mechanism. And his wonderful statement was, for the continuous relative motion between the number of links in a 4-bar mechanism, the summation of shortest and longest link length should not be greater than the other two link lengths. Means if you are having the 4 links, one is 2, other is 3, other is 5, other is 8 mm long, then he is saying this is shortest and this is longest. Okay, I am saying longest is, let us say, 6. So you can say this is 2 and this is 6. So 2 plus 6, the summation of this should always be less than or equals to the other two link lengths. Okay. So if I am saying the shortest link is denoted by S, longest is denoted by L, other two are denoted by P and Q, then Grashof states that the summation of S plus L should be less than or equals to P plus Q. And my dear, this was the statement given by Grashof. And he said if you are going to follow this, you are going to have continuous relative motion. You are going to get continuous relative motion. Now my dear, here you may have a doubt, sir, what is the meaning of continuous relative motion? How from this we will able to get that whether it is double crank or double rocker or what? Then the answer is, you tell me whether this is continuous or this is continuous. Obviously, when we are talking about this crank, it is a continuous motion. When we are talking about rocker, rocker is changing the direction of motion 2 times, here and here. And when it is changing the direction of motion, it has to be at rest. So the point is, in the motion, every time whenever the direction will be changed, the motion will be stopped. It is not going to be continuous. So you must be understanding here that crank guarantees continuity. So when we are saying that you will be getting the continuous motion if this condition satisfies, so you can say if this condition satisfies, we are going to get at least one crank. So at least one crank you are going to get. So this was the statement of Grashof law. I will be telling you a wonderful demonstration now one by one. By looking at that, you will be getting an idea that when we are going to get double crank, when we are going to get crank rocker and all. So I am going to take case number 1 when S plus L is going to be P plus Q. So my dear, this is the condition when we are going to say that Grashof law is satisfied or not. S plus L less than, sorry, it should be less than. So when S plus L is less than P plus Q or S plus L is equals to P plus Q. For both these cases, I am going to show you the discussion what is going to happen. So my dear, if any of these two conditions satisfies, then my dear, first of all, what you will be checking? You will be checking the shortest link is fixed or not. If you will find the shortest link fixed, I would like to say for rotation, shortest is the best link because easy to rotate. You already know the best position is the fixed link. So my dear, best link at best position will give you the best mechanism. And when he was guaranteeing for one crank, the best will be 2 crank. Like if I am going to sell you something and I say just purchase this book, or you can say this, let us say I am giving you this phone, just purchase this phone from me, I am giving you warranty of 1 year. So I am giving you warranty of 1 year. If it is running well for 1 year, it means my guarantee is fulfilled. And if it is having damage, I have to change it. But let us say you are using this phone for 2 years and nothing happened. You will be saying that what a phone it was. Because more than guarantee, if something is running, it means it was a good product. So my dear, here we will say the best mechanism is double crank. I am saying best just in terms like guarantee was for 1 crank and you are getting 2 crank. In that term, I am saying the best mechanism. So this is a trick to remember कि best link, best position, best mechanism. So जब भी shortest link को आप fixed position पर देखो और Grashof law satisfy हो, तो आंखें बंद करके बोल देना है कि सर ये double crank mechanism होने जा रहा है. We will be calling it as double crank mechanism. Then my dear, you will check for the second condition. बहुत ध्यान से देखना, whatever now I am going to tell you is going to be different. First of all, you will see shortest is not fixed and adjacent to shortest is fixed. If adjacent to shortest link is fixed, you will be getting the best link at second best position. So mechanism will be crank rocker, the second best mechanism. Best position, best link, best mechanism. Best link, second best position, second best mechanism, crank rocker. जो Grashof ने कहा वो अभी भी आपको मिल रहा है. You will be getting crank rocker mechanism. अगर shortest link हो जाता है पड़ोसी किसको? Fixed link को. Is it clear? Yes, 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 Vineet. So if we are having this as fixed link and adjacent to this is the shortest link, either here or here. So in both the cases, you will be having the shortest link to be rotating completely. You will get the crank rocker mechanism. Now we are going for the third case where shortest link is neither fixed nor adjacent to fixed. Why I am writing these things? Because first you need to check that. Otherwise, you may get problem in the upcoming cases. And then you will be saying, but it is going to be a coupler. This was a case for which Grashof was failed to give the results. Because as per the Grashof, if condition is satisfied, you must get 1 crank. But my dear, for this case, you were getting no crank and mechanism was the worst one, that is double rocker. But my dear, the credit for this or debit for this was not given to the Grashof. Because here it was said to be misutilization. You have shortest link, you have best position, but you are not using it. You have encounter specialist, but you are not using him. You are putting him in the kitchen. The problem is with you, not with the encounter specialist. So that is the beauty, and we will be calling it as double rocker. So guys, these 3 things will be the result for 1 and 2 cases. For both of them, it is correct. Okay. And in this condition, I would like to say that here shortest is not equals to P, longest is not equals to Q. It means all 4 links are having different length. That is the wonderful case number 1 and 2 for the Grashof law. You can see this is the motion of double crank mechanism. Okay. So for the feeling, I am showing it. This is double crank mechanism. And now you will see the second mechanism, crank rocker. Crank rocker will look like this. Okay. So crank rocker will look like this. You can see here shortest link is the fixed one. You can see here shortest link is the input link. Okay. Yes, this is the beauty. Now my dear, you can see this is also crank rocker mechanism. Okay. And this is the double rocker. So I have shown you all the mechanism one by one, one by one, one by one. Is it clear or not? Yes. So moving further guys, now we are moving to the next case. If we are having the links as SSLL, means 2 links are shortest, 2 are longest. In that case, you will say S plus L is equals to S plus L, because you can say that 2 shortest link and 2 longest link are there. So law is satisfied here as well. And when the law is going to be satisfied, my dear, in that case, you are having 2 possibility. One possibility is this. You will keep L here, S here. And you will keep S here, L here. This possibility will give you parallelogram linkage. Now, my dear, whatever the rule I told you, you go by that. You go by that. If you will be keeping the shortest fix, by rule, you will get double crank. Here, some of you may have doubts, sir. If this is fixed, this shortest is coming at coupler. That's why I have written. First, you will check the fixed position. If any shortest link is present at fixed, no need to check for the coupler. You will check for the coupler if shortest link is not present at fixed and adjacent to fixed. So when you will be keeping shortest at fixed, you will get double crank by rule. And if you are going to fix longest link, then input and output both will become shortest and both will rotate. Then also you will get double crank. So this is the linkage which will always give you double crank. It always follow the condition of Grashof. That's why we call it as golden chain mechanism. Similarly, if you will keep shortest together, longest together, then my dear, this is said to be the deltoid linkage. And when you will be using the same rule here, you will find this will also always follows Grashof. It will always give you at least one crank, either double crank or crank rocker mechanism you will get. So I would like to say this is also golden chain. So both of these are said to be the golden chain mechanisms. Golden chain mechanisms. The wonderful golden chain mechanism. विनीत, इस सीरीज में हम 3 ही टॉपिक डिस्कस करेंगे, पर जो आप बोल रहे हो वो होगा. That will be covered. Whatever you are saying will be covered. Okay, that will be covered in the 3rd class. Okay, so moving further, guys. Now I am moving to the last case. When S plus L is going to be more than P plus Q, then you can say Grashof law is not satisfied. Law not satisfied. When law is not satisfied, you will straight away say that we are going to get double rocker. So my dear, this was the beautiful Grashof law we have seen. So what we understood that, first of all, what we will be doing, now I am giving you the final thing, what you need to check. First of all, you will be checking whether law is satisfied or not. S plus L less than equals to P plus Q or not. This is the first check you will be going for. If that condition is satisfied, you will see whether shortest is fixed or not. If it is fixed, you will directly say double crank. If it is not fixed, you will go to 3rd. Okay. If yes, go ahead. If no, leave it here. So this is S is fixed, you will get double crank. Then we will come here. You will say S is not fixed. S is adjacent to fix. Then you will say crank rocker. Okay? Yes. Then 4th. Here you will write if not. If not. Shortest not fixed. Shortest not adjacent to fix. Shortest coupler. You will say it double rocker or misutilization. So this is how, my dear, you will be solving this question, this type of thing. Okay. And this was the beautiful Grashof law, guys. I hope you guys enjoyed the session. So those who go for the recording of the session, if you have any doubt, you can ask me on the Telegram channel Mechanical by Dheeraj Sardana, or you can join me on WhatsApp as well, mail, Google also. Okay. So Mechanical by Dheeraj Sardana is the channel where you will get PDF of this session. You will also get all the updates, all the examination notification. And tomorrow we are going to have a session with the Bark scientist to get an interview experience with him. Okay. That will give you an idea that how the interview is framed and how the questions are asked, what are the high weightage subjects, how interview is going on. So do attend that. So goodbye, guys, for this session. Thanks for joining. Good night.